Hello guys, welcome to our YouTube channel. Welcome back to Add Maths Plus Maths. We are now going to discuss another lesson in additional mathematics, which is part of our lesson on functions. We are going to talk about modulus functions. And when we talk about modulus functions, it is also called in other countries as absolute value function. Okay? So when I say absolute value, it is always something that is always positive. Okay, decide things that you need to think about, okay, or points to think about. Decide if these rules for absolute values are or always true, sometimes true, or never true. I have x plus y is equal to absolute value of x plus absolute value of y. Is this always true, sometimes true, or never true? It is sometimes true. Why? Take a look at, for example, this one. 5 plus negative 5. What is 5 plus negative 5? It is equivalent to 0. The absolute value of 0 is still 0. You will find out that if I will put 5 here, this will become 5. If I will put negative 5 on the y, then it will still become 5. The absolute value of negative 5 is 5. 5 plus 5 is equal to 10, which is not equal to the 0 a while ago. So it is sometimes true. The same thing with if you are subtracting. So it is sometimes true. Next, how about if I am multiplying? Take for example 5 and negative 5. 5 times negative 5 is negative 25. And if you find out the absolute value of negative 25, it will be positive 25. Take a look at this one. What is the absolute value of 5? 5. What is the absolute value of negative 5? It's still 5. 5 times 5 is 25, which is equal to the absolute value of the product of 5 and negative 5. Okay? Even if it's both negative number, it will still be a positive value. Therefore, it is always true. Same thing as division. And if you square both sides, squaring both sides, you see absolute value of, for example, let's take a negative number. Absolute value of negative 5 is 5. 5 squared is 25. Take a look at this one. What is negative 5? The quantity of negative 5, and then you square, it will still be a positive 25. Therefore, it is always true. Okay? So think about this, and you will notice that if I will square both sides, can I remove already the absolute value sign? Yes. Giving you an idea that if I am solving, okay, if I am solving an absolute value equation, then I can square both sides and get the answer. But there are easier way on how to solve absolute value, and I'm going to introduce to you with this one. Okay? Work example number 5. Letter A. I have 2x plus 1 is equal to 5. The absolute value of 2x plus 1 is equal to 5. How will I solve this? If I am going to solve this, I am going to remove that absolute value and make that 5, or the number on the right side without an absolute value, a positive and negative. Okay? I repeat, I am going to remove that absolute value sign and make the number on the right side of the equation positive and negative. Since you'll have positive or negative value on the inside the absolute value, and we'll come up with a positive number. Okay, so first thing, if I make that number on the right side positive, it will become 2x plus 1 is equal to positive 5, and 2x is equal to 4 by taking away 1 from both sides. Then divide both sides by 2, it will give you x is equal to 2. That's the first solution. The second solution is if I make the right side of the equation negative. So there are only two things that you need to do. First thing, make the right side of the equation positive, and the second thing is make the right side of the equation positive. Okay? Why? Because basically example number is 5. Absolute value of positive 5 is still positive 5. Absolute value of negative 5 is still positive 5. That's why I put a positive and a negative value of the right side of the equation, and then remove that absolute value. So 2x plus 1 is equal now to negative 5. I'm going to take away that positive 1 or plus 1. To both sides, it will become negative 6. So 2x is equal to negative 6. Divide both sides by 2. The other value of x for letter A is negative 3. So there are two values of x. One is 2 and the other one is negative 3. Now, let's check using our graph. Okay, of course, you don't know yet how to graph modulus function unless you have studied graphing of modulus function already. But I want to show you the graph of a modulus function. The graph of 2x plus 1 is this, with an absolute value or with a modulus sign. This is the graph. Now, if I will put the graph of y is equal to 5, okay, you see the green line, okay, it intersect at 2 points, or they intersect at 2 points, the graph of the modulus function and the graph of the number, which is y equals 5. They intersect at 2 points. 1 point, you will see that x value is negative 3, and the other point, you will see the intersection is positive 2. Okay? Thus, we'll give you an idea that the solutions of the equation absolute value of 2x plus 1 equals 5 are positive 2 and negative 3. Now let's move on to letter B. Same thing. 4x minus 3, make the right side of the equation positive. So 3x is equal to 3. If I take away x from both sides and add 3 to both sides, it will give me an answer that x is equal to 1. And the second solution is if I make the right side a negative number. If I make the right side a negative number, it will become 5x is equal to 3, because 4x plus x, since I'm going to add both sides by x so that I can move this going to the left, and negative 3, I am going to add both sides by 3, so 3 will be on the right side. That will become x is equal to 3 over 5, or 0.6. Okay, so that is letter B. Now I want to show you again with the graph. This is the graph of the absolute value of 4x minus 3. You will notice that, okay, I was not able to discuss with letter A a while ago, so I will discuss with letter B. There are no lines below the x-axis. Why? Because the basic meaning or the basic definition of modulus is everything is positive. So there should be no negative value of y. Okay? So everything should be positive. Okay? There. Now, let's move on to showing where is y equals x. Y equals x is at the middle. Remember, y equals x is on this line. Okay, if I will draw that, this is y equals x. Okay, and so if it is y equals x, there are two intersections. This is 1, the value of the x is 1, and this is 3 over 5. Okay, the value of x is 3 over 5. So there. So the intersections itself will show you what are the solutions. Now, that is if you know how to graph a modulus function. So, if you know how to graph the modulus function, then you can solve. So how will you know how to graph the modulus function? Okay, watch out for another video about graphing of modulus function, which I will be doing later. Okay, now let's move on to letter C. X squared minus 10 is equal to 6. So you have now a quadratic expression. Okay, remember, if you have a quadratic expression, it's not anymore a line. Okay, it's a curve. Okay, and when you call it a curve, it is either a parabola, ellipse, or something, or a circle, or a uh, oblong. Okay, I don't know if you know what's the meaning of oblong, but uh, this this one will, or ellipse. Okay, so this one is a graph of a parabola, but let's not focus on that this time because I'll be teaching you anyway how to do that. Okay, so I want to focus on the equation that I have here. The modulus of x squared minus 10 is equal to 6. So again, it's a modulus, so I want to make the 6, or the right side of the equation, a positive and a negative. So if I want to make that a positive or a negative, let's do first the positive. It will become x squared equals, you add both sides by 10, it will become x squared is equal to 16. And if you square root both sides, you'll have two values, a positive and a negative. So 4 and negative 4. Okay? Now let's make that 6 a negative number. Okay, x squared minus 10 is equal to negative 6. If I take away, or if I add 10 to both sides, it will become negative 6 plus 10. Okay, which is equivalent to positive 4. And then if I square root both sides by 4, x is equal to positive or negative 2. So there are 4 values of x here. I have 2, negative 2, 4, and negative 4. How will I show it if I know already how to graph? Remember, the graph of x squared minus 10 is something going straight like this. But it's a modulus, so whatever I have below, I am going to flip it going on the positive values. Okay, so I have that. Next, if I will draw y is equal to 6, what are the solutions? Y equals to 6. And you see that green line? Okay, there are intersection points between the green line and the graph of the modulus of x squared minus 10. One is this point. This point intersection is negative 4. The next is this point. This point, the intersection, the value of x is negative 2. Then this one positive 2, and this one positive 4. So these are the intersection points that will give you the answers. X is equal to 4 and negative 4, or x is equal to 2 and negative 2. Okay, next. Let's move on to letter D. D, you'll have x minus 3 is equal to 2x. The modulus of x minus 3 is equal to 2x. Okay, first we'll make that positive. on the right side. We'll make that 2x on the right side positive. It will give you an idea that it will become x minus 2x is negative 2x. You move that negative 3 will become positive 3, but it's negative x is equal to positive 3 will give you an answer that x is equal to negative 3. Okay, let's try to make the 2x a negative. That's the second solution. X minus 3 is equal to negative 2x, therefore 3x is equal to 3. Thus, it will give you an idea that x is equal to 1. Take a look at the graph. This is the graph of the modulus of x minus 3. Okay, or y is equal to the modulus of x minus 3. And let's try to graph y is equal to 2x. Y equals to 2x, the graph is this. You will notice that there is only one solution, which is x is equal to 1. Why? Because it won't touch anymore the graph on x is equal to negative 3. Therefore, my answer is only 1. I am not going to consider negative 3 as my answer. Okay, let's move on to some examples from our past year papers, which are past year questions. Solve for the modulus of 4x minus 3 is equal to x. If I am going to solve for the modulus of 4x minus 3 equals x, I am going to make the right side of the equal sign positive and negative. So solution number 1, I'll make it positive. Solution number 2, I'll make it negative. Okay? So if I have this, I'll have now 4x minus x is equal to 3. The first solution will suggest to me that it will become 3x is equal to 3, then x is equal to 1. The second solution will suggest that it will become 4x plus x is equal to 3, and it will become 5x is equal to 3, therefore x is equal to 3 over 5. Second example. Solve the equation absolute value of 2x minus 9 is equal to x minus 3. Okay, now, I was not able to give you an example like this a while ago, but I'm giving you now an example. Okay, when you make the right side a positive and a negative, it should be like this. Okay, you will notice that I will leave x minus 3 as x minus 3. Okay, and then I am going to put a bracket on x minus 3 because x minus 3 is considered to be one quantity and I'll make it a negative number. Okay, so those are the two solutions that you will have. So therefore, I'll have 2x minus 9. The first solution will suggest that it will become 2x minus x is equal to 9 minus 3. That negative 9 becomes positive. Okay, because I need to add both sides by 9 and then I need to take away x from both sides. Okay, to combine the similar terms or like terms. So x now is equal to 6. So that's the answer for the first answer or the first value of x. Here, I want to distribute this negative sign to x and negative 3. It will give me an idea that 2x minus 9 is equal to negative x plus 3. Okay? If I want to add both sides by x and 9, I can combine the like terms, which is 2x plus x is equal to 3 plus 9. And 2x plus x is 3x. 3 plus 9 is equal to 12. I'll divide both sides by 3. I'll have now x is equal to 4. Okay? It's like we are mastering our solving of linear equations in this while doing this. That's why in additional mathematics, okay, you will be doing a lot of solving linear equations, solving quadratic equations. Okay, so be familiarized with all your steps in solving linear equations. Next, find the values of x for which x plus 2x plus 3, the absolute value of that, is equal to 1. You will notice that there is an x on the left side that is added to the modulus of 2x plus 3. This x needs to be moved first to the right side of the equation, and let's do what we have done in the previous example a while ago. Okay, so it will become the modulus of 2x plus 3, or the absolute value of 2x plus 3, is equal to 1 minus x. Okay, what we have done a while ago on the previous example is that we make 1 minus x positive and negative. Okay, so first solution, I made it positive. The second solution, I made it negative. Again, don't forget your bracket, because 1 minus x is one quantity. Okay, I have that. It will become 2x plus x is equal to 1 minus 3. Okay, and then 2x plus x is 3. 1 minus 3 is negative 2. Okay, it will become 3x is equal to negative 2. And x is equal to negative 2 over 3. Okay, I'll distribute the negative sign for the second solution. It will become negative 1 plus x. I'll take away x from both sides, so 2x minus x is equal to negative 1, and then I'll take away 3 on both sides. Negative 1 minus 3 is equal to negative 4, so x is equal to negative 4. So these are the answers for the last example for this lesson, modulus function. Okay, if you have learned something from this video, don't forget to like and share. Those who haven't subscribed yet and you want to learn more lessons, techniques, skills in additional mathematics and mathematics, please subscribe and click that bell button so that you will be updated with our new exciting lessons in additional mathematics and mathematics. Thank you.